the conversion of solid from one shape to another. Fatima was helping her mother in serving food. She inverted the bottle filled with water in the jug. Does the quantity of water change? Of course not. Okay, let us take some clay. Let us mold it into a ball. Now, I want to reshape it and make a star of the same clay without adding or taking out clay from it. The volume of the new shape, that is star, will be the same as the volume of the earlier shape, that is the ball. This is what we have to remember when we come across objects which are converted from one shape to another, or when a liquid which originally filled one container of a particular shape is poured into another container of a different shape or size. To understand what has been discussed, let us consider some examples. Example: a cone of height 24 centimeters and radius of base 6 centimeters is made up of molding clay. A child reshapes it in the form of a sphere. Find the radius of the sphere. Solution: volume of cone is equal to 1 by 3 into pi into 6 into 6 into 24 centimeter cube. If r is the radius of the sphere, then its volume is 4 by 3 pi r cube. Since the volume of clay in the form of the cone and the sphere remains the same, we have 4 by 3 pi r cube is equal to 1 by 3 into pi into 6 into 6 into 24 centimeter cube. That is, r cube is equal to 3 into 3 into 24 centimeter cube, which is equal to cube of 3 into cube of 2 centimeter cube, which gives r is equal to 6 centimeters. Therefore, the radius of the sphere is 6 centimeters. Let us take one more example. Selvi's house has an overhead tank in the shape of a cylinder. This is filled by pumping water from a sump, an underground tank which is in the shape of a cuboid. The sump has dimensions 1.57 meters into 1.44 meters into 95 centimeters. The overhead tank has its radius 60 centimeters and height 95 centimeters. Find the height of the water left in the sump after the overhead tank has been completely filled with water from the sump which had been full. Compare the capacity of the tank with that of the sump. Solution: the volume of water in the overhead tank equals the volume of the water removed from the sump. Now, the volume of water in the overhead tank cylinder is equal to pi r square h is equal to 3.14 into 0.6 into 0.6 into 0.95 meter cube. The volume of water in the sump when full is equal to L into B into H is equal to 1.57 into 1.44 into 0.95 meter cube. The volume of water left in the sump after filling the tank is equal to 1.57 into 1.44 into 0.95 minus 3.14 into 0.6 into 0.6 into 0.95 meter cube is equal to 1.57 into 0.6 into 0.6 into 0.95 into 2 meter cube. So, the height of the water left in the sump is equal to volume of water left in the sump upon L into B. Putting values we have 1.57 into 0.6 into 0.6 into 0.95 into 2 upon 1.57 into 1.44 meters is equal to 0.475 meters is equal to 47.5 centimeters. Also, capacity of tank upon capacity of sump is equal to 3.14 into 0.6 into 0.6 into 0.95 upon 1.57 into 1.44 into 0.95 equals to 1 by 2. Therefore, the capacity of the tank is half the capacity of the sump.